In this video, we will talk about the side effects of function calls in Python. What are side effects, you may ask? Well, side effects are any change that a function makes to the state of the program or the environment outside of its own scope. For example, a function that writes to a file or modifies a global variable has side effects. Side effects are not necessarily bad, but they can make your code harder to understand, test, and debug. Therefore, it is good practice to minimize the side effects of your function and make them as pure as possible. A pure function is one that only depends on its input parameters and returns a value without changing anything else. Pure functions are easier to reason about, reuse, and optimize. What happens when you pass an immutable object, such as a string or a number, to a function call's parameter? First, let's remind ourselves what immutable objects are. Immutable objects are objects that cannot be changed after they are created. For example, if you assign a string to a variable, you cannot modify the string itself. You can only reassign the variable to a different string. Now, let's see what happens when you pass an immutable object to a function called parameter. For example, suppose we have a function called add1 that takes a number as a parameter and returns the number plus 1. If we call this function with an immutable object such as 5, what will happen? When we passed x to the function call, Python created a kind of a local copy of x inside the function. This copy is called num, a local variable, and it is only accessible within the function. When we modified num by adding 1 to it, it did not affect the original variable x outside the function. We only changed the local copy. When we return num from the function, we got a new value that was assigned to y. As you can see, the value of the global variable x did not change. It is still 5. The value of y is 6, which is the result of adding 1 to x inside the function. Why did I say a kind of a local copy earlier? It was to simplify the explanation. In fact, Python passes the reference to the object passed in the parameters. This will become more obvious with a function that takes a tuple in the argument and returns a tuple where all the numbers have been increased by 1. The function add1 takes only one argument. As the argument is a tuple, which is an immutable object, it cannot be modified. We need to create a temporary list named +1 that will store the values of the tuple +1. Once the computation is completed, the function returns a tuple version of the list +1. When the function is called, the parameter numbers receive the reference of the tuple myNumbers, and therefore points to the same object. A new list is created, and the value of each element of the original tuple is added 1 before being appended to the list +1. The list is then converted into a tuple before being returned. Once the function terminates, you can see that the tuple myNumbers is unchanged, and the tuple otherNumbers points to a different object. This means that passing an immutable object to a function call's parameter does not change the original object. A local copy needs to be created in order to be modified within the function. The original object remains unchanged. This is an important concept to understand when working with immutable objects in Python. It can help you avoid bugs and confusion when writing and debugging your code. Mutable objects, on the other hand, can be changed or modified after they are created. Lists are such an example. Now, when you pass an object to a function called parameter, Python does not copy the object or create a new one. Instead, it passes a reference to the same object that you passed in. This means that if the object is mutable, the function can change its content or attribute. And those changes will be reflected outside the function as well. For example, let's refactor or add one function, so it takes a list as a parameter and adds one to each element of the list. As you can see, the function add1 works as expected. It modifies the list that we passed in as an argument, and the changes are visible outside the function. This is not a pure function, as it has side effects. Specifically, it modifies the object passed in the parameters. This can be useful in some cases, but it can also lead to unexpected results or bugs if you are not careful. For example, let's refactor our function add1 so it has a default value for the parameter numbers. In contrast, this second implementation of the function has a problem. The problem is that we used a mutable object as a default value for the parameters. This means that every time we call the function without an argument, it will use the same list object as a parameter. And since the function modifies the list by adding 1 to each element, the default value will change every time we call the function. This can cause confusion and errors if we don't realize what is happening. So, how can we avoid this problem? One way is to use immutable objects as default values for parameters and make a copy of the mutable object before processing the copy rather than the original object. In this example, we use none as the default value for the parameters. None is an immutable object that represents nothing or absence of value. When we call the function with an argument, it makes a copy of the list passed in the parameter on line 6, modifies the copy, and returns it. NewList and MyList refer to two different objects, and MyList remain unchanged. When we call the function without an argument, it checks if the parameter is none and creates a new empty list object, if it is. Then returns it. This way, we avoid modifying any existing list object or changing the default value. To summarize, passing mutable object to function calls parameters in Python can be useful or problematic depending on how you use them. You need to be aware of how Python passes object by reference and how a function can modify mutable objects. To avoid or reduce the side effects of function calls in Python, you should try the following where applicable. First, use local variable instead of global variable whenever possible. Global variables are accessible from anywhere in the program, which means they can be changed by any function that uses them. This can lead to unexpected behavior and bugs. Local variables are only visible within the function that defines them, so they cannot be affected by other functions. Secondly, use immutable data types instead of mutable data types whenever possible. Immutable data types are those that cannot be changed once they are created, such as strings and numbers. Using mutable data types, such as a list, can cause side effects because they can be altered by any function that has access to them, and immutable data types are safer because they cannot be changed by anyone. Thirdly, make a copy of the function of the mutable object passed in the parameters. Then apply the computation to the copy before returning it. Thank you for watching, and see you in the next video.